All right, Miss Teasley here. We're going to finish this last section in this unit on modeling with variation. So we're going to start off with filling in some of this information. So direct variation. All right, so it says direct variation. Y varies directly as x, or y is directly proportional to x if there exists a non-zero real number k called the constant of variation such that for all x, y equals kx. So this is a formula for direct variation. All right, direct variation means like as one value goes up, so does the other. So basically something like the more you study, the higher your test scores. All right, so that would be an example of direct variation. We're going to look at now how to solve a variation problem. So it says step 1, write the general relationship among the variables as an equation. Use the constant k. So every single example, we're going to be using k as our constant of variation. All right, then it says step 2, substitute given values of the variables and find the value of k. Step 3, substitute this value of k into the equation from step 1, obtaining a specific formula. So we'll come back to the specific formula part. And then substitute the remaining values and solve for the required unknowns. So I'm going to refer back to these steps as we solve these equations or these word problems. So the first one says, at an average speed, the distance traveled by a vehicle varies directly. So as soon as I see that, I'm going to highlight, when you want to look out for words like this, varies directly. All right, so what varies directly? The distance traveled by a vehicle varies directly as the time. So the first sentence, from that, I can get my first equation. I'm going to use d for distance and t for time. So it says d varies directly. When you see the varies directly, that's your equal k part. Directly as what? As time. So the variable t for time is going to go right beside the k. So that's what this first sentence says, d equals kt. That would be my step 1. Step 2 says substitute given values of the variables and find the value of k. So when I go to my next sentence, I should be able to plug in values for d and t so I can solve for k. So it says if a vehicle travels 156 miles, so this is my d value, in 3 hours, that would be my t. So I'm going to stop there because the last part is actually solving the whole problem. So I'm going to stop right here and solve for k. So I have d equals 156, all right, and then I have the time is 3. So 156 equals k, t is 3. So to solve for k, I'm going to divide both sides by 3. All right, 3 goes into 15 5 times. It goes into the 6 twice, so this would be 52. So k is 52. So it says, so that was step 2. So substitute, find the value of k. Then it says substitute this value of k into the equation from step 1. This is step 1. Obtaining a specific formula. So the specific formula for this word problem would be d equals k is 52t. This is the formula, and they'll ask you for the formula. So this is the actual formula that we're going to use to solve the problem. So moving on, I'm going to take the formula and write it over here again. So d equals 52t. So now to finish it off, it says, let me just highlight this. Find the distance. So we're looking for distance. It will travel in 5 hours at the same average speed. That average speed they're talking about is this 52 here. So basically, find the distance. So we're trying to find d. We know k is 52. And we know that it travels in 5 hours. So this is actually the t value I'm going to put here. So times 3. So the distance it will travel in 5 hours would be 156. All right. Oh, it says 5 hours. I put 3 back in there. So my bad. So this should be a 5. No, that didn't look right. All right. So 52 times 5. So 260. This is your D value. So the time that it travels in 5 hours, 260 miles. All right, so we'll be using these steps to solve all these variation problems. So it says direct variation as an nth power. Let n be a positive real number. Then y varies directly as the nth power of x, or y is directly proportional to the nth power of x. And for all x series, it's a non-zero real number k such that, so this is direct variation. So y equals k. So notice how you have this k, and that x to the n goes right beside the k. All right, so we'll run into that when we get to some more problems. As a matter of fact, let me write an example. Let's say we see y varies directly as x cubed. Then that will look like this: y equals k, and the x cubed would go beside the k. So that's how you would set it up. So that's how you would set something like that up. That's what they're saying here in this definition: direct variation as nth power. All right, let's get down to inverse variation. So inverse variation is y equals k over x. So direct variation, the variable x goes beside the k. Inverse variation, the variable x goes below the k. So just remember that when you see inverse variation, think about a fraction. Let n be a positive real number. Then y varies inversely as the nth power of x, or y is inversely proportional of x. All right, let me see if I put that in. Let's see what word they're using. Yeah, inversely proportional to. All right, so inversely proportional. All right, so here's your inverse variation. Again, this one that they have here, they have x to the nth power. X could have an exponent. So if n equals 1, then y equals k over x, and y blank blank is x. It varies inversely. All right, so let's get to an example so we can kind of pull this together. So with these variation problems, you want to go line for line. You want to start with the first sentence and pull out that first equation so you can solve for k. So let's kind of see what we have here. In a certain manufacturing process, the cost of producing a single item varies inversely. As soon as you see something varies, you want to stop there and kind of pause. So varies inversely. So C, we want to let C equal cost. And then it says the cost varies inversely as the square of the number of items produced. All right, so I'm going to let N stand for the number of items. All right, so let's write our equation. So the equation, the cost comes first. So C varies inversely, so equals K. And whatever follows this is going to go below the K. The square of the number of items. So this is over the number of items squared. So that's how you write the equation. The next step is to solve for K. So going to my next sentence, it says if 100 items are produced, each costs $1.50. So with that information, I should be able to solve for K. So the cost is $1.50. I don't know K, but I know the N value is 100. and we have to square the n value. So I'm going to multiply both sides times 100 squared. So I can get k by itself. And I'm going to leave it like, and the reason I'm using the 100 square, especially if you're using a TI calculator, you kind of want to keep it in that square form when multiplying it out. So let's see, 100 squared times 1 point times 1.50. So that's 15,000. So this is 15,000. That's my k value. So remember, once you get k, you'll be able to get the actual specific formula, the formula. So going back to the beginning, I'm going to take this equation and plug in 15,000 for k over n squared. So this is the formula. So you'll probably be asked for the formula. So to finish this off, it says find the cost per item. So we're looking for C. If 250 items are produced. So 15,000 over 250 squared. So I'm going to put that in my calculator. So 15,000 divided by 250 squared. So I get 0.24, which is 24 cents. All right, that's the cost, 24 cents per item. All right, so we did an example of direct variation. We just did one of inverse variation. Now I want to look at combined variation, problems that combines direct and inverse together. So joint variation, when you see the word joint, think about direct variation. The only difference is you're going to have more than one variable. So when I see joint variation, I think about direct variation. That means the variable goes beside your k. So it says let m and n be real numbers, then y varies jointly, all right, as the nth power of x and the nth power of z. So this is what they have here. So they have the y equals k, like we're used to, and it says varies jointly. So whatever follows the word varies jointly, that's going to go beside k. So the nth power of x is here, and then the nth power of z is right beside it. So that's how you write it. So it says note that and in an expression y varies jointly as x and z translate as the product. So y equals kxz. The word and does not indicate addition. All right, so we'll look at the next example. And this is going to involve joint variation. So it says the volume of a cylinder varies directly. So bam, I'm automatically going to stop there and see what's going on. So this is varies directly. The volume of a cylinder. So I'm going to let V represent my volume. So V equals K. And it says varies directly. So that means whatever follows this varies directly is going to go right beside the K. So it says varies directly as the height and the square of the radius. So the height we want to let equal h, and r will be our radius. So varies directly as the height and the square of the radius. So that would be the formula. And normally it would say varies jointly. So don't be surprised if you see the word varies jointly. So the volume of the cylinder varies jointly as the height and the square of the radius. So we already have our first part. The next step is to solve for K. So it says a cylinder, so we should get all the variables, the values for all the variables other than K. A cylinder with a radius of 5, so I have my R value here, has a height of 10, so that's H, and a volume of 785. So 785 is V. I don't know K. H is 10 and the radius is 5, and I need to square the radius. So this is 785 equals K times 10 times 25, which is 250K. And then I'm going to divide both sides by 250. to get K. So I'm going to put this into decimal. 785 divided by 250. Oops. All right, so I'm going to change it to a fraction. So I'm going to hit, so in decimals, if you see the number 1 here right beside, I'm going to hit that little circle. So reduced form is 157 over 50. So K is 157 over 50. So now with this K, I can write the actual formula. The formula would be V equals 157 over 50 HR squared. This is the formula. So now to finish and to actually solve the problem, it says find the volume. So I'm here now. Find the volume of a cylinder. So that's what we're trying to find. We're trying to find V that has a radius of 10 and a height of 15. So I'm looking for V. I have this 157 over 50 here. The H value, so the height is actually 15. And the radius is 10. So this would be 10 squared. So I'm going to put all this in my calculator all in one step, just like I see it here, to get the actual answer. And again, if you're doing this using a TI calculator, you're going to want to put all this in together, because your calculator will go in overflow mode, and it'll give you like a scientific notation answer. So just want to give you a heads up on that. 157 over 50, 15 times 10 squared. So 157 divided by 50 times, what was it? 15 and 10 squared. So 4710 is the volume. All right, so hopefully you can do the next example, which I believe is the last example. So this will be a good stopping point to stop, pause the video, and try this example. All right. So I hope you got a chance to pause the video and try this example. All right, this looks like it's a lot going on, but we're going to just take it one sentence at a time. So Vanessa has determined that the number of children enrolled in her daycare center varies directly. So stop right there. Varies directly. What varies directly? So it says, I'm going to start back from the beginning. Vanessa has determined that the number of children enrolled in her daycare. So this is the number of children. So I'm just going to use C for children. You can use X and Y's if you like X and Y's. I just like to use the first letter of the variable. With the amount she spends on advertising per year, and inversely with her weekly charge for each child. So I have a lot going on. It varies directly, which again you might see varies jointly. Well, no, sorry, not varies jointly. This is combined. So it's a direct variation. Whatever follows the word direct, it's going to go beside the K. And it says varies directly with the amount that she spends. All right, so let's just say A stands for the amount she spends on advertising per year, and inversely, so we have a word inversely now. So whatever follows the word inversely is going to go below the K. Inversely with her weekly charge for each child. So W would be our weekly charge. All right, so let's see what we have going on. So going back to the beginning, the number of children, C, varies directly. So that's my equal K part. Whatever follows this is going to go beside the K. Varies directly with the amount she spends. So I'm going to put A beside it. And then it says varies inversely. So whatever comes after the word inversely is going to go below the K. So I draw a fraction bar and I put the weekly charge below the K. That's the equation. So this is a combined variation problem. This is a problem that combines inverse and direct together. All right, this year she spent $900 on advertisement. So I got my A, which is $900. She charged $150 per child per week. All right, so this is the charge, her weekly charge. So this is actually W. And then she had 51 children enrolled. So that would be actually C, the number of children. I'm putting number of children. So 51 equals K. The amount she spent on advertisement is 900, and the weekly charge is 150. So I'm going to simplify this. So this is 51 equals 90 over 15K. So let's see. 90 divided by 15, which is 6. You could have actually just did 900 over 150 in the beginning. Right? So I could go and do the 900 over 150. I was just trying to simplify to make it small, which is 6. So that's 6K. So 51 equals 6K. To get K by itself, divide both sides by 6. So K equals 51 over 6. So my formula is going to be C equals 51 over 6, that's K, and the A over W goes beside it. All right, so you could put A over W in parentheses because it's still going to be a fraction. Your case happens to be a fraction also. So it says next year, if she spends $1,000 on advertisement, so that's A. So the 1,000 goes here for A. Charges $170 per week. That would be my 170 here. How many children should she expect to enroll? So when I multiply these two fractions together, that's going to give me my final answer. This is the formula. And now I'm trying to get the final answer. So multiply this times 100 over 170. All right, so let me go back to this. So 51 over 6. Then right beside it, times 100 over 170. All right, the final answer is 5. All right, and that's